Hey everyone, and welcome to PlatformCon 2024. Today I'm going to be talking about how you can implement infrastructure as code for efficient platform engineering. Software engineers build things, right? They build cool things on the front end, on the back end, on the cloud with AR and VR. But the truth is, for software engineers to build and scale global products, they need platform engineers. These two teams need to work together to make sure that those cool things that they actually build can actually get deployed, can actually get used, and can even get and stay built at the end of the day. Because the truth is, even the most productive and most talented software engineers can be slowed down by inefficiencies when there isn't a strong platform foundation around. I mean, prior to platform engineering, we've had times when software engineering teams have been doing both the software work as well as the platform work. But, like I said, in this talk, I'm going to be telling you how you can do better platform engineering by leveraging infrastructure as code. But before I get right into it, I would want to just quickly introduce myself. Hi, my name is Adora, and I'm a senior platform engineer currently working at DB. I'm also the founder of Nexus Scale, which is a nonprofit currently helping people start and scale their tech careers by connecting them to job opportunities and other kinds of simulated work experience opportunities. I used to work at Microsoft prior to joining DB. I spent about 4+ years at Microsoft. I've been I've received many awards. I've been featured on like many blogs. I've written 3 books on cloud engineering, and I'm also a speaker. I've spoken at over 150 conferences all around the world, and I'm a DJ as well. So yeah, enough about me. Let's get right into the meat of this talk. So, platform engineering is a practice that focuses on building and maintaining self-service infrastructure platforms for developers. The rise of cloud computing and DevOps has led to a growing need for platform engineering. Platform engineering teams are now focusing on building and maintaining self service infrastructure platforms that developers can use to deploy and manage their applications. And infrastructure as code is a core component of platform engineering because it enables automation of infrastructure provisioning and management. And this automation obviously leads to improved efficiency, consistency, and repeatability for these platform teams. When you're building out a platform engineering team, I believe that there are 3 things that everyone should focus on. The first thing is the people, and then the process and the platforms. And like every team or every business, the people is the foundation. I think it's very important to create a team of people with the right skills, technical skills. So whether you are um, an engineering manager or the VP of the organization that is trying to create a team of platform engineers to build out the developer platforms that other engineers building out the technology in the organization are going to use. The most important thing is that you want to find people with technical skills, and you also want to find people that are passionate about platform engineering and excited about the challenges that it presents, because these things are very important. Of course, soft skills are also very important because people don't work in isolation, they work alone. So you want to hire people that are good collaborators, have effective communication, and they're problem solvers at the core of it at the end of the day. Because if you don't get this part right, no matter how much you implement and how well you structure the next two, you're still not going to have that kind of effective team. And the next thing, like I said, is process. When you have the right people, then you should establish, clear and efficient processes to guide their work. So things around like issue tracking, deployment procedures, monitoring practices. This is how we've set up on call rotations here. This is how we've set up a way to do deployments. This is how we've set up a way to create these resources in this particular order and deploy them in this particular order. This is how we've set up the mechanism that we support these teams with, and this is how we've set up documentation. Just giving like examples of things that you want to integrate into your process depending on the kinds of project that you're building, right? Because these well-defined processes, they help with making sure that There is consistency, efficiency, and obviously when things are streamlined, then you could possibly have fewer errors. Errors are not inevitable, let's be honest, but at least you can reduce the number of times that these errors occur. And the final thing is about platforms. This refers to the tools that the team will build and the tool that the team will use to build. So you want to select platforms that align with your business, platforms that have like a good community, things that people are using, and just sort of like go from there. And you also want to train, if they don't have that skill set yet, you also want to train your team to make sure that they're able to use those platforms and be, or rather to use those tools and be successful to build out the developer platforms that you need. These are cloud agnostic IAC tools that you can use to build out your IDP. Terraform is the most popular choice. People use it because it's flexible and it supports multi-cloud environments, and it uses HashiCorp, which is a human readable configuration language for defining your infrastructure. Ansible is also pretty popular. It's a popular configuration management tool by Red Hat, and it's also being used for IAC. And it uses YAML playbooks to define configurations and automate your deployments. And Pulumi is relatively new, but recently a lot of people have been using Pulumi. And I think one of the major things driving the Pulumi adoption is the fact that it allows you to write IAC using familiar programming languages. So if you're even building out your platform team, you can build your platform team out of your engineering team, because the regular programming languages that people use every day, the JavaScripts, the Pythons, the C Sharp, the Go's, are languages that you can use within Pulumi to create your own platform. And if you are building like developer centric platforms, for example, that can scale into doing beyond deployments, and you are building it and taking the approach to infrastructure as software, not necessarily infrastructure as code, then Pulumi is also, a good way to sort of think about that as well. And I mean, like, there are other ones that are platform or cloud specific. So when you think of like AWS and you're thinking CloudFormation or CDK, or with Azure and you're thinking, okay, Azure Bicep or writing ARM templates, or with Google and you're thinking Google Cloud Deployment Manager as well. These are like their own specific IAC tools that you can use to build out those applications or those platforms or those deployment pipelines that would help software engineers that are working and building on top of these cloud infrastructures do their things better and quicker. So the next thing I sort of want to talk about now is how we actually design the infrastructure blueprints for the IDPs that we design. And I'm going to use a bank called Ably Bank, for example. Obviously not a real bank. But I'm using it as an example and saying that Ably Bank has 13 engineering teams. They're working on various products, and these products are ranging from like large e-commerce platforms to a suite of mobile productivity apps, right? So different kinds of apps within the bank, within that system. And we can see here like these are like different teams that can exist within Ably Bank or even any bank at all, right? There's like the payments team, the core banking team, the fraud and security team, risk management, data and analytics, open banking and APIs, um, the compliance team, the trading team, the wealth management team, digital lending team, and the customer onboarding team. All of these teams are interacting with the infrastructure team or the platform engineering team, depending on what it's called in the company. And this is because this infrastructure team, this platform team, is responsible for the deployment and the releases and the entire automation of the code that the software engineers in these other team writes. So they have to interact and sort of like work together. And going back to this case study, Ably is building an IDP to optimize the development processes for these teams. And I'm just going to show you how they might approach designing the infrastructure blueprints for their IDP, because this is the meat of the talk. This is exactly what the talk is about. The first thing is that it's important to understand the needs of the developers that the platform engineers are building these tools for. Who are your target users, and the IDP is something that would cater to the software engineers from the 13 teams because they're building, web apps, mobile backends, microservices, different kinds of things. And the developers, let's say they're facing delays in provisioning infrastructure because they're using old tools, um, obsolete processes, archaic processes, or they're even doing manual deployment. So obviously there's no standardized approach to building and deploying these applications. So you want to understand these developers' needs so that you assure that as a platform engineer building these internal developer platforms, you are actually sort of solving the problem and not creating a whole new problem. The next thing is to define the infrastructure components, and there are multiple reasons why this is important. The first thing is consistency. When you define these infrastructure components that you know that the different teams are using, you can standardize your infrastructure. So you are defining infrastructure components that ensures that your team are building and deploying applications in a consistent fashion. And obviously, this can reduce errors because that's the whole point in the first place. When you also define these components, you find out that most times different teams reuse the same kinds of components. So you're able to create reusable building blocks, and teams can use those infra libraries that you build, or those composed or modular systems that you've built in their own infrastructure, so that they don't have to reinvent the wheel and build out things all the time. They can use those reusable modules that you've created. um Another reason why it's important to define your infra components is because of governance and control. When you define your components, you sort of make it clear, where the ownership and resource management efforts actually lie. Because now teams can be granted, access to specific components that they need because those components are defined and there is no conflict, and people are not sort of like sharing resources, or they don't have like undefined processes for how to share and access resources in terms of like access control or other kinds of things around security compliance. Sort of like you want to make sure that that's structured in a way. And the infrastructure team or the platform team can make sure that that happens, right? The next thing is scalability and maintainability. When you break down your IDP into independent components, right? People are, or rather engineers on the team, are able to use what works for them in a way that is maintainable, and everything just sort of like works. And it also creates the opportunity for collaboration because now there is a common language for infrastructure, there is a common tool that the entire company, or the entire product's infrastructure is built on top of. And what this means is that teams collaborate better, everyone understands what resources are available and how they fit together, and there is clear communication across different engineers on the team, and context is shared across. Now, in terms of like the infrastructure components, there are different sides to it, right? It's not just the cloud infrastructure, like, oh, the secrets managers or the virtual machines or the virtual networks and subnets and all of that, things that you basically need to provision. But there's more. So we're talking about like the actual core infrastructure. That's what platform teams will deal with. So typically platform teams handle like these five core things that are just on this screen right now. The core infrastructure of the team, right, or rather of the products, the networking bits of it. So when you're thinking traffic managers, load balancers, API gateways, how do we want to do this, how do we want to move this traffic around, sort of like all of the networking bits, um for that application. Also security, most times it's not just going to be security in isolation, right? If there is a security team, most times those two teams will collaborate, the platform team and the security team. The security team typically collaborates with everybody to be honest, but there's also a security bit to building out these developer platforms, and there's monitoring and logging as well as CI/CD pipeline. So this entire chain is something that a platform engineering team can manage, and just have other software engineers writing code and working with these platform engineers to ship the code that they've sort of like um written, or rather working with these platform engineers to use the developer platforms that they've built to manage these different parts of the software that requires this expertise. um Another thing is also to prioritize flexibility, creating modular design, and also leading with a cloud agnostic approach. Ably isn't locked to a specific cloud provider, for example, right? So Ably is going to use Terraform to create their cloud agnostic infrastructure blueprints. And if they ever want to move from the current cloud provider that they're using, it's just going to be easy to switch to a new provider still in Terraform, since all the platform engineers have context on Terraform, basically automating your provisioning as well using IAC tools. And it goes back to what we're talking about in the beginning of IAC being the tool or the bedrock for efficient platform engineering, because the main keyword at the heart of everything at the end of the day is automation, consistently finding ways to improve automation and make things better. And IAC does automation effortlessly for infrastructure as well as security policies, right? There are other important things to consider as well. The first one is documentation. Let's say, for example, Ably builds out a platform that is supposed to help the different teams that work in the bank to do deployments better. So let's say we've built out this automatic deployment engine for you. All you need to do is write YAML or JSON that has the kinds of resources that you need, and we would work around provisioning them for you, right? So let's say, okay, there is a specific way or there's a specific library or a specific format that these configurations have to be written, right? Um if there is no good documentation, right, teams will struggle because they will be reaching out to infrastructure teams all the time to understand how to use what exactly. So it's important to also, when you're building out these tools, invest in writing documentation that all the different people within all the different engineers within the company that you are supporting sort of like understand. I know that when you're in the company, there's room for 1P support, which is very good because you can just always find somebody on Slack, on Teams, regardless of any messaging tool that you use, and reach out to them and say, hey, I noticed you're on this team. I'm having this problem. Can you help me? But sometimes, just to reduce the amount of people that reach out to you for 1P support, because that can also affect your productivity if you have things that you are supposed to be doing and deliverables, you want to make sure that you have the right documentation. The next thing is feedback. Create some kind of process, right, that keeps that feedback loop coming, because there is always going to be room for improvement. The first iteration of the IDP isn't going to be the perfect iteration of the IDP. So you want to make sure that you are getting feedback and supporting these other engineering teams as the platform team, because that's literally what your role is kind of about. And it also ties into continuous improvement. And I think there's one thing I would really like to touch on, which is customization. There should be room for customization in whatever platform that you build, because although there's going to be a lot of things that are shared across, let's say three teams are building serverless applications, or four teams are building with event driven and microservices architectures and things like that, right? So they use the same kinds of infrastructure. Not everybody would build with the same thing. Many people would, but most times where that difference exists, don't make it hard for the teams that are doing things a bit differently to key into your own solution. Create the room for customization and make it as flexible as possible. But in the context of, but in the but as a result of making it flexible, make sure that you don't make security a trade-off. So you want to add access control, you want to create, opportunities for people not to be able to have access to things, have, access control lists. You want to maybe do JIT access and have that your authorization strategy in a way that makes sure that the entire services are secure. Um, I'm going to leave you with this, which is that by investing in platform engineering, you're not just building tools, but you're building the foundation for a thriving developer ecosystem within that company. And if you are somebody that is working on developer tooling outside of a company, maybe for the broader developer community or developer ecosystem as a platform engineer, know that you are also part of the foundation that is helping the developer ecosystem all around the world thrive. Now more than ever, this is a field that is becoming very important. And I just want to leave you with the five things that platform teams care about, which is core infrastructure, CI/CD, monitoring and logging, networking, and security. Um, when you consider these five things appropriately, you build a wholesome platform for everyone, every kind of developer, and they're able to build things and build great products on top of that platform. Thank you so much for watching my talk. I'm available on Twitter at Adora Nwodo in case you want to chat about this or have any questions because there's only so much I can say in a 15 minutes presentation. I hope you enjoy the rest of the conference and you enjoy every other talk from every other speaker. Have an amazing day. Bye.